Hello, everybody. Welcome to this weekend Python bootcamp. My name is Gpal. So excited to have you all here for this class. So just a quick introduction about myself first. My name is Giri. I go by Gpal. I'm a self-taught programmer. And since the start of 2018, I've taught over about 4,000 students online. This is something that I started last year and something that I absolutely enjoy doing. It's such a thrill to do this, and it's amazing to see so many students come in and walk away with knowledge about programming. So what's the game plan for today? In short, the plan is really to help you master the basics of Python. So if you have no experience in programming, you have never touched programming at all, don't worry, I'm going to explain everything from the basics so things are going to be clear. You're going to have a sense of what's going on. If you do have knowledge about programming, but you're not familiar about Python, this is also going to be helpful because I'm going to teach you the basic Python syntax. And we're going to have in-class exercises where I'm going to list out stretch opportunities so that you can stretch yourself. So whether you belong to either one of these camps, you're going to be in good shape here. And at the end of this session, you're going to learn basic Python syntax, things like variables, operators, if-else statements, and functions. And we're going to practice these skills in-class activities, in-class exercises. And there are three main principles that guide all these classes that I offer. The first is that we learn best by practicing. So I'm going to keep the lecturing to a minimum. And instead of that, we're going to focus a lot on in-class exercises so that you can consolidate the concepts that I teach you. The second is that given the limited time, we need to prioritize the concepts that we focus on. And I believe in the 80-20 rule. 80% of the value comes from understanding 20% of the concepts out there. So the focus today is really going to be on the most critical 20% of concepts in Python so that you have a good foundation to proceed on from here. And the third idea is that we learn best in a peer-to-peer setting. So my hope is that if you run into any issues, you share your code with others and you help debug the code of others as well. And when we have this kind of a social learning experience, I think learning becomes a lot more fun and a lot more effective as well. So getting on with matters, we're going to be using two different tools for this weekend Python bootcamp. The first is Discord server app, and the second is Replit. So Discord server is going to be the place where you can ask questions and you can get all the updates about future classes. And if you haven't signed up for a Discord server app, go to this link, tinyurl.com/let's-learn-club. And let me show you the important channels that you need to know for today's class. So go ahead and sign up to our Discord server app if you haven't yet. And for those who are following us on YouTube as well, so now is a good time for you to sign in to our Discord server app. So go ahead and sign in. And when you're signed in, I'll proceed on to the next step. I'll show you all the important channels that you need to know for today. Okay, so let me highlight the most important channels that you need to know for today. So today, the most important channel is going to be the programming exercises channel. So this is going to be the place where if you run into any doubts, you can post your questions, you can post your code, and then others can help you out. So I'm going to monitor this channel constantly today. And there are also going to be other peers who can come in and help you out if you run into any issues. So this is going to be the most important channel. And if you do have any future class requests, you can drop them in this specific channel. But I want to just highlight, this is the most important channel for today, programming exercises. Okay, so take that in mind. And then the next tool that we're going to be using today is called Replit. So Replit allows us to code on the browser itself. So that's nice because we don't need to download anything beforehand. And it makes it super convenient to share code with others. So if you run into any issues, it makes it a lot easier to share your code with others and debug it. And it's also free. So let's go ahead and sign up and write our first line of code. So go ahead and sign up with Replit. And after you sign up, I'm just going to wait here for about 30 seconds to 1 minute. I'll show you the important features of Replit. Okay, so everyone inside Replit right now? Okay, it should be fine. Okay, let's proceed. So this is Replit. So what I want you to do is take a look at the top right-hand corner. Take a look at the plus create new REPL button. Go ahead and click that, and then type in Python. Right? Click the first option. Don't select Python 2.7. We're not going to do Python 2.7. Today we're going to do Python 3.6. So go ahead and click the first option. Okay, you can leave all of these things blank and then hit create REPL. Okay, and then you're going to see a screen like this. And now let me explain the important things that you need to know for today. So the stuff that you see on the right side, that's called the interpreter. That's going to be where our code is going to run. Okay, so the right side is the interpreter. The left side, this stuff here, is the place that we're going to write our code. And this part here, that's the name of this replit. You can change it. So let's say I want to put in Python weekend bootcamp, right? You can change the name to whatever you want. And now, suppose you run into some kind of an issue and you need some assistance. You need somebody to take a look at your code. What you do is you hit this share button, and then you're going to see this link. And what you can do is go to the programming exercises channel and post it here and explain what's the issue that you are facing. And others can help you out. So those are the main logistics and housekeeping matters here. Okay. So let's go ahead and write our first line of code. So this is almost classic programming 101. The standard is always to start out with print hello world. So let's do that. Let me type it out and then let me explain what's going on here. So let's go ahead and type out print hello world. Okay? And if you want to run your code, what you do is you hit this run button in the center. So go ahead and run it. And then you should see the code execute, and then you should see hello world printed out. So let me explain what's going on here. So print is what's called an inbuilt function. I'll explain more about what functions are later, but these are essentially reusable pieces of code. And print, what it does is that it just outputs that specific message. And in this case, we said, hey, Python, I want you to print out this specific message, hello world. And the way that you comment on Python is to use this hash symbol, this pound symbol, and then you write out your comment. And comments are extremely critical, especially when you work on big projects, especially when you're collaborating with others and you think that you're going to take a look at your code again, because you want to make sense of your code and you need to explain why you're doing certain things. So without the simple programs that you're doing, the comment section might not seem as necessary, but eventually, you do need comments to keep track of what's going on. So it's a good habit to start writing comments early on itself. So that's just to get you kind of warmed up with Python and Replit. Now, let's take a step back for a moment and let's just think about what is programming at a very abstract level. Well, when you think about it, programming is all about information processing, right? You take in inputs from the users, you do some kind of processing, and then you output it. At a very abstract level, that's what pretty much all programming is. When you think about an application like Reddit, right? Users sign in, that information is created in a database, and then you subscribe to different subreddits. And based on your subreddits, there's some kind of algorithm that decides, what are the hot posts, what are the posts that you're going to be most interested in, and then that's being displayed in your front page. So programming in general, it's all about information processing. But information can come in different shapes, right? You have integers, you have numbers, like integers and floats. Sometimes you have text, stuff that's called strings in programming. So information comes in different types. And that's what we're going to focus on. We're going to make sense of the different data types in Python. So that's going to be the first part of this weekend bootcamp. So we're going to learn specifically about strings. Strings are things that we colloquially know as text, right? So hello world is an example of a string. Anything in Python that's between double quotation marks is a string. So this is a string, this is a string, this is a string. All these are strings. Even a number that's within double quotation marks in Python is actually a string. So anything that's in between quotation marks, double quotation marks in Python is a string. Even if it's between single quotation marks, that's also considered a string. But in this case, let's stick with double quotation marks. So suppose you want to know the type of the data type that you're working with. One of the inbuilt functions that you can use is called type. So print is an inbuilt function that we just learned before. Type is another inbuilt function. And with type, what happens is you get to know the data type that you're working with. So let's type in type and then Python. And let's say we want to print it out. Okay. So essentially, we're asking, hey, Python, what type is this specific object? It's actually a string. So let's just go ahead and run it. And you see class str, and str stands for string, right? Let's type in the number 8, but let's put it within the quotation marks. This is also going to show you that this is a string. So right now, we have all these strings. That's fine, but we need some way of accessing them, right? And how can we access them? To access these strings, you need to store them somewhere, right? And the way that you do that in Python is to create variables and assign these strings to these variables. So let me show you an example and then explain it. So let's say we want to create this variable called name, right? And then let's assign it. Right? You can key in your own name. Go ahead and try this exercise as I run this class as well. So that's the best way that you can learn. So what's going on here? You're saying, hey, Python, go ahead and create this variable called name. And a variable, the way that you can think about it is, it's essentially like a storage box, right? You're creating this storage box to hold certain items. You're saying, okay, there's this name object, there's this name storage box, and store this string called gpal. So the next time you call this variable, let's say you type in print name, what you're going to see is name is going to bring this string that's gpal. So you run it, and then you find that this string is being outputted. So there's certain rules concerning the naming of variables. So generally speaking, we start out with a alphabetical character at the start. You're not supposed to use a number at the start, so meaning this wouldn't be considered proper. And there are a couple of other rules, but I don't want to get into the very arcane matters here. I'm going to pass you notes later on after this class is done. And in that class notes, I'll detail the specific rules concerning variable naming. But the key thing you should take note is make sure that it's continuous. So this is going to be considered improper. You need to make sure that it's continuous when it comes to a variable name, and make sure that you start with an A to Z character at the start. That's the way that you make sure that you have a proper variable name. So far we have created variables, we have assigned strings to them. So one of the things that you want to do sometimes is to concatenate strings together. So what that means is you want to combine strings together. So let's say we have this additional variable called hobby, and let's say we put coding, right? Maybe we want to create this sentence which says, look, this is my name, hi, my name is this, and this is my hobby, right? I enjoy XYZ hobby. Let's say we want to create a string like that that combines 2 or more strings together. How can we do that? So I'm going to show you the old way of string concatenation, the way that you combine strings, and then I'm going to show you a more convenient way that's available on the latest version of Python 3.6, which is what we are going to be using, which is what we're using right now. So the old way that you used to concatenate strings looks something like this. You would say print I'm going to print it out and say, my name is, and then you insert the variable name, and then you continue on. I enjoy, and then you add the next variable. So let's run this. Okay, I need to put a space here, right? So this is perfectly fine, but this looks a bit messy, especially when you have multiple variables coming in. It doesn't look very neat. So let me show you the new way that you can do it in Python 3.6, and it's way more convenient. So let me show you how that looks. It uses this method called f strings. So the way that you do this in Python 3.6 is you start out with f, and then you have the double quotation marks, and then you type in the same string, my name is, but then you have this curly braces, and then you insert the name of the variable. So same thing, okay? And let's comment this out. We don't want this here. Let's do it again. And you find that you get the same output, right? So this is the way that I would highly suggest that you go about concatenating strings together, combining strings together, because this looks a lot neater when you have multiple variables coming in. So this is the method that I highly encourage people to use. So I'm going to teach you one more concept before we move on to the first in-class activity. So far, we have been hard coding the variables. So we create the variables, and then we assign them specific string values. That's fine, but it's going to be way more exciting if we can get input from users, right? That's what we want to do. So the way that you do that is, let me show you how you can do it. Let me take this out. Let's say we want to get both the name and the hobby from the user. So the way that you do that is, first of all, let's go ahead and create the name, the variable, and then use this inbuilt function called input, and then you insert the question you want to ask the user. What's your name? Okay, and then let's just print out the name to check that we got the right name. Okay, let's run it. Key it in, and then you print it out. That's it, right? So this is the way that you get input from the users. Use this inbuilt function called input, and then you insert the question within the parentheses, and whatever the user outputs, whatever the user enters, that's going to be assigned to that variable that you list here. So that's how you get input from the users. So right now, what we're going to do is that we're going to create, using our knowledge of strings and getting input from users, we're going to create what's called a MadLib game. So let me show you how that works very quickly, and then spend about 5 minutes working on it. So let me go ahead and show you all how that works. So some of you might be familiar with MATLAB games, some of you might not. So let me explain how this game works. So in this game, what you do is that you get input from users. You ask them, okay, can you specify 2 adjectives? Can you specify 2 nouns? And then what you do is you create like a poem or a small paragraph, and then you insert the user input into the poem, into the paragraph, into that text. You do a mashup, and then it creates some kind of it has this humor effect, and it creates something funny. So let me show you an example MATLAB that you can take a look at to draw some inspiration. So this is an example of a MATLAB game. Okay, so what's going on here? So in this MATLAB game, this specific program is asking for a noun, a place, an adjective, a noun. So let's just, for the sake of demonstration, let me just randomly select key and stuff here. Let's type it in. So the program has gotten input from the user, and then they mash it up in this creative, funny line. Be kind to your weight-footed grapefruits, for a duck maybe somebody's sin. Be kind to your grapefruits in Lebanon, where the weather is always Irish. You may think that this is the factory. Well, it is. So the point is, it doesn't make any sense. That MATLAB itself doesn't make any sense, but you are just creating something funny. You want a mashup of user input combined with your template. So go ahead. I'm going to share this link both on YouTube, and it's about 10 work on this MATLAB game. So let me go ahead and share this link with y'all right now. And if you have any questions about strings, getting inputs from users, now is a good time to ask me in the programming exercises, monitoring that feed so I can respond to your queries right now. And after you're done with this exercise, go ahead and share your code with others so that they can take a look at this as well. Take another 3 minutes or so to wrap up your MATLAB game. If you have any questions, go ahead and post your code so that others can help you out as well. Okay, anyone done with the MATLAB game right now? Okay, take about 1 more minute and wrap up your MATLAB game. And when you're done, go ahead and post it so that others can take a look at it as well. Okay, let's get back right now. Let me show you a couple of examples that some of the students did. I took a look at them using another screen. Some of them are really, really interesting. So let's go ahead and take a look at how you can approach this MATLAB game. So let's take a look at this response. Let's see what's going on here. So the objective was we wanted to create a MATLAB game, and the requirement is we need to get at least two nouns and two adjectives, and then we want to combine them together to create a MATLAB game. So that's what we want to do. Let me run this program and let me explain what this program is doing. So let's enter a noun. Let's say I put in tree. Let's put a cat. Let's put a fast. Now enter an adjective. And let's say I put tall. And this, what does this MATLAB game say? Once upon a time, there was a fast tree who challenged a tall cat. Right, that's neat. That's what we want, right? We want to get user input, and then we want to concatenate that together and create this MATLAB game. Yeah, this is an awesome response. This is an awesome MATLAB. So some of you might have noticed I included this stretch exercise for those who wanted to kind of stretch themselves, who had a little bit of time. And the question is, how can we output uh, each line separately? So in this case, we don't need to do that. I mean, because it's just one line. But if you do have multiple lines, what you could do is that you can use this uh, keyword, it's this backslash n, and that what happens is that your string gets broken up into two separate lines. So you get a new line. So let's do the same activity again. Let's say we put in uh, tree, cat, oops, fast, tall. Now what you find is that it breaks up into uh, two different lines. So that's what this backslash n does. This is called an escape character. You can read more about it. I just wanted to share that, and I'll also include additional notes about this in the notes when I send that to y'all later on. So let's get back on track. So far, what have we learned? We have learned about strings, the specific. No, we talked about data types more generally, and we have learned about strings. But strings aren't the only data type out there. There are lots more data types. So that's what we're going to do next. So we want to learn about numbers right now. We want to learn more about numbers. So numbers in Python come in two different forms, mainly speaking. You have integers and you have floats. So integers, think of them as numbers that you usually count with that don't have a decimal point. So 8 is an integer, 9 is an integer, 0 is an integer, -1 is an integer. And floats are stuff that have a decimal point associated with them. So 8.0 would be a float. 3.02 will be a float. Suppose we do want to test this out. What we can do is, remember, we know this inbuilt function called type. So we can say type, let's put in 8.0. So this is going to show us that it's an integer. So let's run it. And sorry, 8.0, this is a float, sorry, 8.0 is a float, right? Let's say we take away this decimal point, and this is going to tell us that this is a integer. Yeah, int, which stands for integer. So key thing you need to understand is that Python differentiates between numbers that have a decimal point and numbers that don't have a decimal point. So you need to keep that in mind. And just as you can do normal, arithmetic operations on numbers, you can do that in Python as well. Things like addition, subtraction, multiplication, division, and so on. So let me show you how you do that in Python. So if you want to add two numbers together, add two integers or floats, you just put plus. You just add them up, right? This is going to give you 2, right? That's quite intuitive. Let's say you want to do a subtraction. You type in 4 minus 1. That's going to give you 3. So you run it, and you get 3, right? So addition, subtraction. You can also do multiplication and division. So let's say we want to multiply 4 by 5, right? That's going to give us 20. So you see 20. You can also divide numbers. So let's say we want to do 4 divided by 5. It's going to give us 0.8. So all this is pretty intuitive, but there are also slightly more unintuitive mathematical operators in Python, and that's what we're going to cover next. So a slightly not so intuitive operator is the quotient operator. So suppose we say print 11 /2. So this is going to give us the quotient. So in this case, the quotient is 5, right? So that's the main quotient. So that's what this // does. Suppose you do want to get the remainder. What we use is that we use this percent sign. It's called a modulo. So you run it, and this is going to show us 1 right now, because 1 is the remainder when you have 11 divided by 2. Another slightly unintuitive mathematical operator is the exponent symbol. So let's say we want to raise 2 to the power of 3. What you do is you put in 2, and then the asterisk, the multiplication symbol, twice, and then by what power you want to raise the base to, and then you put this. So this is equivalent to 2 to the power of 3, which is equivalent to 2 to the power of multiplied by 2, multiplied by 2. So this is going to give us 8. So these are the main mathematical operators that you're going to be using. Now, the thing I want to emphasize here is that when you have complicated mathematical operations, you need to be very careful with the order of operations. So suppose we have a statement like this, print 10 minus 3 multiply by 3. So what do you think the response to this statement is going to be? What's going to happen when we run this statement? Well, there's a certain order of operations, and multiplication takes precedence over subtraction. So this is the first operation that's going to be executed. So 3 multiplied by 3 is equal to 9. So 10 minus 9 is equal to 1. So when you run this, this is going to be 1. So it's a mistake to assume that Python is just going to evaluate it from left all the way to right. So you need to be mindful of that. So broadly speaking, parentheses takes precedence over other mathematical operators. Of course, multiplication, division takes precedence over addition and subtraction. I'm not going to share all the rules right now. I'm going to make sure that the notes that I send you include all the different rules. But the key takeaway is if you have something that's complicated in terms of mathematical operations, you want to include parentheses so that it's clear what's the operation that is taking precedence. One last thing I'm going to mention before we move on to the next activity is whenever so remember in the last section, we got input from the user. So we said, look, let's say we say favorite color or favorite number. Right? We said the way that you do that is you have this inbuilt function called input, and then we key in the question, enter your favorite number. Now, the thing that you need to understand is whenever you get inputs from users, it's always going to be in a string format, right? So suppose we want to test it out. So we say print, and then we type in, we want to find the type of the favorite number. Okay, so let's do this. Let's say we key in 8. Even though 8 is a number, we find that the Python's telling us that it's actually in a string format, because whatever user input you get is going to come in the format of a string. Now, in Python, there's this thing called data type conversion. So what you can do is that you can take something that's of a string value and convert it to a float or an integer, right? And you can also, of course, convert things that are integers to strings as well. But right now, I'm going to show you how you can convert a string to an integer. So the way that you do that is you just wrap this whole input statement, this whole string, with int. So what that's doing is it's converting this string into an integer. So now if you run this code again, let's say we put in 8 again, now it's telling us that, hey, you know what? This favorite number variable is now an integer. That's because we wrapped it with this int. So it's int, parentheses, and inside of it, it's any string that you want to convert into an integer. So now let's go ahead and try out another activity. So this is going to be, we're going to build a tip calculator. So let me share with you the exercise so that you can take a look at it. Okay, so go ahead and take a look at the link that I just shared with you all. So let me explain how this program is supposed to work, and then I'll give you about 5 minutes to work on this. So the idea is we want to get two types of user inputs. I mean, we want to get the bill amount, and then we want to understand the tip percentage that the user wants to give. And then we want to do the mathematical computation, and then we want to output the total bill amount that the user needs to give. So that's how this is supposed to work. And to do this, you need to use knowledge about how you use the input function, how you convert it from a string to an integer, and then the basic mathematical operations that I just ran through. So the time right now is about 11:10. Let's take about 5 minutes to work on this, and then let's reconvene back at 11:15. And if you have any questions about what we just covered about integers, go ahead and, uh, and post any questions. And those who are done with the tip calculator, go ahead and share your code on the programming exercises channel. Okay, take another 2 more minutes and wrap up your tip calculator exercise, and then we'll get back and run through how Boolean operators and how Boolean data types work. Okay. Try wrapping up your tip calculator. If you have any issues, go ahead and post it. We're going to resume in about a minute. Okay, I think folks are done. So wrap it up, right? 20 more seconds, and then I'll continue. I'll show you how you can approach this exercise and then move on to the next part. Okay, so let's keep moving ahead. Let me show you how you can perhaps approach this program. Let's take a look at a sample response here. Okay, let's run the program first here, and then let's see how the code here specifically works. Okay, let's enter the bill amount. Let's say we enter 100. Let's say we want to tip them 20%. Okay, neat. The total value that you need to pay is 120. Okay, so what's going on here? So first of all you have this variable called bill amount. Uh, you take in the input from the user, which comes in a string format, and then you convert it to an integer. It's fine that you do it as an integer here. You can also do it as a float because it's possible that the bill amount isn't an integer. It has some decimal points, but this is fine for this activity. Then you take the tip percentage, right? And then what happens is, oh, wait, give me a second. Okay, wait. Okay, there's a small error here. So what happens here is we wanted to calculate the total bill value, and the total bill value is actually equal to the tip percentage divided by 100 multiplied by the bill amount. So let me show you what I mean. So in this case, what's going on is there's just an addition of the bill amount and the tip percentage. The tip percentage isn't exactly equal to the the value that the user keys in here. So what we want to do is we want to create this variable called tip value, right? And then tip, because the user is going to key it in an integer format, we want to divide it by 100 and multiply it by the bill amount. So that's going to be the tip value, the additional amount that you're tipping. And the final value is going to be the bill amount plus the tip value. Okay, so let's run that right now. So the bill amount is 50, and you want to tip, let's say you want to tip 20%. So you find that 20% of $50 is $10, so the total value that you need to pay is $60. So the key point I want to highlight here is that sometimes, even though you don't have any syntax errors, the program is executing properly, there may be certain errors in the logic of the program, so you just want to be very careful about that. Okay? So any questions about this before we move on to Booleans? Any questions about this? Okay, great. So some of you might have noticed, this program is fine, but it runs into issues, right? Instead of, let's say, entering a positive value into the bill amount, let's say somebody is very mischievous and they key in a negative value. Let's say they key in negative 100 and the tip percentage is 20. This is odd, right? You see that the total value that you need to pay is a negative number. That just doesn't make sense. So the point here is, if the user enters a negative value, we don't want the code to run. So we need some kind of a control statement to make sure that that validates, okay, is the user input accurate? If it is accurate, let's proceed on with the execution of the code. But if it isn't, then we don't want the code to execute. We want, let's say, an error message to be outputted. So we need an if-else statement to control the flow of the statement. The control is the flow of the program. But before we learn about if-else statements and while loops and for loops, we need to first of all understand how Booleans operate. So, we talked about strings, that's one data type. We talked about integers and floats, those are two other additional data types. The next data type that we need to get well acquainted with is Booleans. So Booleans come in two forms, very simple. It's either true or false. And let's say you want to understand the type that you're working with, you just type in type. Let's say we type it true here, you run it, you're going to see bool printed out, and bool here stands for Boolean. So the thing with Booleans is that Booleans become a lot interesting when you have compound Booleans, right? When you add them together with an and or statement. So, in life, we see these kinds of statements. So suppose we see a compound sentence like Jane likes the colors orange and blue, right? So in this case, for this statement to be true, Jane needs to like both orange and blue. So let me show you what happens when you compound, when you add up these Booleans with and. So let's say we want to type in true and true. So this is going to evaluate to true, right? Because if both these statements are true individually, the compound sentence is also going to be true. Let's cut this out. So we type in true and true, that's going to be true, right? But instead, suppose you have true and false. What's that going to evaluate to? Right? Suppose Jane does in fact like orange, but she doesn't like blue. Then this whole statement is going to be false. So if you run this, this is going to show false. And let's suppose that both these statements individually, both these conditions individually are false. So when you have false and false, that's going to evaluate to false. So this exercise might seem a bit pedantic, but the moment we get to if statements, it's going to be a lot clearer why you need to get a grasp of how compounding of booleans works. So far we have learned how to compound booleans using and. Another keyword, another operator that comes in handy when it comes to booleans is also or. So let's say we have a statement which reads Elon likes the colors red or blue, right? And let's say we go true or false. Okay, so there are two conditions here, right? Elon likes the colors red or blue. So for this statement to hold true, you just need one of these conditions to be true. So let's suppose that Elon does like the color red, but he doesn't like the color blue. Is this statement still accurate? Yes, we have the intuition that it is. So when it comes to an or compound operator, you just need one of these booleans to be true. So if it's true or false, that's going to evaluate to true. But let's suppose that it is true or true. That's also going to evaluate to true because you just need one boolean that's true when it comes to or. But suppose it's false or false. So meaning Elon doesn't like the colors red, he doesn't like the color red, and he doesn't like the color blue as well. Is this statement going to be true? That Elon likes the colors red or blue? No, because none of these conditions are met. So when it's false or false, that statement's going to evaluate to false as well. So let's run this. So you find that when it comes to Booleans, you typically don't assign Booleans to variables. You can do it, it does happen, but it doesn't happen very often. What typically happens is that you have these Booleans that are created when you compare different variables, when you compare integers or floats. So let me show you a couple of mathematical operators that result in these Booleans. So let's say we have the greater than symbol is 3 greater than 1, right? So this is going to produce the Boolean true. So the greater than is one of these Booleans is 3 greater than 1. That's going to evaluate to true. Let's run it. So you find that it does evaluate to true. You can also flip it around as 1 greater than 3. So that's going to be false, obviously. Right? And you can also have greater than or less than. That's also, these are also operators that you can use. Another operator I want to show you, which comes in really handy, is the equality operator. So equal, equal. So this is asking, is 3 in fact equal to 1? So that's going to be false. And then the opposite of this is not. Is it not equal to? So that's the exclamation point with the equal sign. So this is asking, is 3 not equal to 1? And that's true because 3 isn't equal to 1. So that's going to evaluate to true. So once again, all this might seem a bit pedantic, but it's going to be a lot clearer when I show you how if statements work and why you need to have a grasp of how Boolean operators come together. So far, when it comes to Booleans, we have learned about the different Boolean types, true and false, what happens when you combine them together, and how you can create them using all these mathematical operators like equality, not equal to, greater than, equal, greater than or equal to, and so on. So going back to the tip calculator exercise. So what we were concerned about is what happens if the user enters a negative number, something that's not positive, right? So let me show you an example of an if statement that can help avert situations like that. So let's suppose we hard code the bill value. Let's go with 100. So when it comes to if statements, the way that you do it is you put an if, and then you specify the condition. So in this case, I want to check, is the bill value greater than 0? If it is greater than 0, I want to say, look, print great. Let's continue on. But suppose it isn't, meaning the bill value isn't greater than 0. Let's say I wanted to say, look, print error message. Nope. Something value needs to be. So what's going on here? So let me explain what's going on here. So as I said, when it comes to if statements, you start with the keyword if, and then you specify the condition, right? In this case, I'm taking this variable and asking, is it greater than 0? So what happens is, if it is in fact greater than 0, you proceed on to this code block, and this code block executes, and that is it. It stops. It just moves on. This doesn't get executed at all. You just move on to line 7, line 8, and it just keeps on continuing. But suppose the bill value is in fact negative. This is going to evaluate to false. So this code isn't going to be executed, and you're just going to move on to the else statement, and this section of the code is going to be executed. So let's run an example here. Right? So now the bill value is positive, so you get this message. Great, let's continue on. But in the case that it's negative, let's type in -10. You get this message. Nope, bill value needs to be positive. Because what's happening is, because this is false, it goes straight to the else statement, and this is being outputted. So I want to mention a couple of things here that you need to take note of, especially when you're approaching this from other languages. Suppose you have a background in Java or another language. In Python, when you have a separate code block, you don't mark out the code block using braces, right? That's not how it works. You use spaces. You use tabs or spaces to indent. So it's using indentation that you mark out. You demarcate these separate code blocks. In Replit and many other development environments, what happens is the moment you have an if statement, you're trying to mark out a separate section of code, it automatically has this indentation. But what that also means is you need to be really careful when you're copying code from the internet, because you have no idea whether they're using tabs or spaces, whether it's going to match up with the code that you're using. So that's something you need to keep in mind. So make sure you understand how this indentation works. Indentation in Python is to mark out code blocks. So that's something you need to take note of. The second thing you need to take note of is, when it comes to if statements, what's necessary is just the if statement. You don't actually need to have an else statement. So you can do without this as well. So that's perfectly fine. But the reason why you have the else statement typically is because you want to create a response if, in fact, your if statement doesn't, if the if condition, the condition that you specify in the if statement doesn't evaluate to true. So that's why typically you have the else section as well, to take care of what happens when the condition isn't met, but you don't actually need to have it. So that's something you need to take note of. Now, suppose you have, in this case, it's pretty simple. We just want to check if it's positive. It's positive. We have a specific section of code to run. If it's negative, we have another piece of code to run. But suppose we have multiple conditions. We need to check across multiple. We need to have multiple checks. We don't need to have multiple conditions that we want to check. So let me motivate this example by thinking about, let's say you have a final score for an exam. Let's call it 97, and you have to assign a grade to this score. So let me show you the wrong method of doing it, and then let me show you how you can use this keyword called elif, which stands for else if, to do it a lot faster, in a lot more effective way. So this is the wrong method. Okay, I'm going to show you the wrong method first. Let's say we say if final score is greater than 97, is greater than 93, we say grade equal A. So this is the wrong method. So let's say we want to check if it's an A minus. If final score less than 93 and final score is greater than 90, and grade is equal A minus. And you can keep on continuing. So this is what you can do, but this is the wrong method. Why is this? I mean, this is perfectly fine. You can do it this way, but this isn't going to be efficient, because why? Suppose your final score is in fact 97. What's happening here? The Python program is going to run. It's going to ask, okay, is the final score greater than 93? Yes. So you get a variable called grade, and A is assigned to that grade. So if this is done, you don't need to consider all these additional if conditions. You can just skip them, right? But if you write multiple if statements in succession like this, what's going to happen is even if this condition is met and you have a grade variable created with a string value assigned, you're still going to go ahead and check these if statements. So that's not going to be computationally efficient, right? So the way that you can do it in a more efficient way, is to use this keyword called elif, which stands for else if. So let me show you how that works. The same thing, to use else if, you start with the if statement, if final score greater than 93, grade equal A. But else if, so meaning if the first statement isn't evaluated to true, you want to move on to this else if, final score less than 93 and final score greater than 90, you want the grade to be A minus. And then you can continue listing all the else if statements. Let's say you want to put, I want to just put one more else if final score less than 90 and final score greater than 80, say grade equal B plus. And then what you want to do is, let's say we just want to have a catch-all situation. I don't want to list out all the grade levels. We just want to say grade equal less than B plus. So the key takeaway here is that with else, so let me explain how this program works, and so that you can understand what's the value of this keyword else if, elif here. So once again, the final score 97. So Python decides to evaluate, okay, is the final score greater than 93? Yes. So you create this variable called grade and you assign it to A, and that is it. It just exits the whole program. That's it. But suppose the final score isn't greater than 93. Let's say it is 91. What happens? This evaluates to false. So you move on to the next elif statement. Is the final score less than 93? Yes. Is the final score greater than 90? Yes. Grade equal A minus, and you completely exit the whole if, else, this whole evaluation here. So this is a far more efficient way of running a if else if loop here to check multiple conditions. So once again, the best way to learn this is through practice. So we're going to have an in-class exercise here to consolidate our understanding of how if statements work and how Booleans work. So I'm going to share the link with you all in the uh, programming exercises section and our YouTube channel. So let me explain how this specific exercise is supposed to work, and then I'll give you all about 5 minutes to work on it, and then we'll get back and learn about how for loops and while loops work. Okay, so this is, okay, let it load up for a while. Okay, it's taking a little long to load up. Okay, let's just give it a little while. Let's let it load up. Okay, great. So let me explain this program. So we want to create a program that takes in an integer input from the user, right? We want to take a integer input from the user, and then we want to check if the number is positive, negative, or neither. So meaning 0 is neither positive nor negative. So we want to write using if a program that evaluates a number that's given from the user and checks if it's positive, negative, or neither, and output that message. So that's what this program is. Take about 5 minutes. It's about 11:35 right now. Take about 5 minutes to work on this, and if you're done, go ahead and share it on the programming exercises channel, and then we'll continue with while loops from here. Okay, we have a couple of responses coming in. Okay, take another 2 more minutes. I think people are good with this exercise. So take another 2 more minutes, and then we'll get back. Okay, 1 more minute, and then we'll get back. We will review this exercise, and then we'll move on to while loops. Okay, let's get back right now. So let's review response here. Okay, so let's take a look at this exercise and how you can approach it. So here's a response we got from a student. Let's run the program first. Okay, so the program is asking us to enter a number. Let's say we enter 90. So okay, that's great. That's positive. That's correct. Let's say we put in minus 10. Negative. Yep, that's right. Let's put 0. Okay, great. It shows that it's 0. So let's see what's going on here with the program. So we have this variable called input, and then the user, we have user input here, and that's being converted into an integer with this int. So there's data type conversion going on. And then there's this else if else statement here. So if the input is greater than 0, we have positive. Else if it's equal to 0, right? You have print 0. Otherwise, the catch-all statement here is if neither of these conditions is met, it's going to be negative, and that's why you have this output here. So this is neat. This is a great response. And if you have any questions, go ahead and post it so that either me or someone else can help you. So let's move on to learn more about while loops. So far, let's just kind of just stand back a little bit and focus on what we have learned. So we have learned about the data types. We have learned about strings, integers, booleans. We have learned about how we can control programs using if. So in the same spirit of learning how to control programs better, we're going to learn about while loops. So how do while loops work, and why do we need to know how these while loops work? So the thing with if statements is that the Python program only evaluates it once. So in the case of the final score program that I just wrote, it's just going to evaluate it once. And in this case, that's fine. But in certain cases, you want to evaluate the condition multiple times. And until that condition is false, you want the program to run. So let me give you an example. Let's say you're creating this a game show or a trivia quiz, right? And let's say you want to you're asking the user a certain question, and you want to keep on asking till they get the right response. So you can't do that with an if statement. It's not going to work nicely. That's where a while loop comes in handy. So let me explain the syntax of a while loop first, and then I'll show you an example, and then we can work on an in-class exercise. So the way while loops work is you start with the keyword while, and then you enter the condition. And if the condition is met, you write the code that executes. Okay. So let's say, let's say we want to create a quiz. Okay. And let's say we're creating a quiz about who is the founder of Tesla. So let's say we hard code this variable called founder Tesla, Elon Musk. And then let's say we type in proceed. We create this variable called proceed. Let's make it true. Let's say while proceed is true, while proceed, meaning this, as long as this is true, let's ask the user the question, who is the founder of Tesla? So let me type out this code, and then let me explain how this is working. And then let's say within this while loop itself, if the user response is equal founder Tesla, which is the answer that we have hard coded here, we wanted to print out congrats. And then we also want to change this condition, proceed to false, because we don't want to let it run again. But if in fact the user response isn't correct, we want to have an else, print, please try again. So let me explain what's going on here. So right now, we have created a while loop, and it's going to evaluate this condition, proceed. So proceed, in this case, we have hard coded it to be true. So the program is going to run. It's going to ask for the user's He's going to ask this user this question: who is the founder of Tesla? And whatever the user inputs, that's going to be assigned to this variable called user response. And if user response is equal to the right answer, which is what we have hard coded here, it's going to say print equal congrats and proceed equal false, because we don't want the program to proceed any further. But in the case that it isn't correct, you're going to say, hey, please try again, and the same question is going to repeat. So let's run this program. Let's test this out. Let's say we put in the wrong answer, Jeff. Please try again. Let's say we put in the right answer. Congrats, and it stops. So the key point you need to notice here is that when you create a while loop, you don't want it to run it infinitely, right? So you need to make sure that at some point it breaks, because otherwise it's just going to hog up the whole program. It's going to get stuck. So in this case, what happens is we have this condition, proceed, right? We have hard-coded it to be true at the start, but in the case that the user gets the question right, we change it to false. So when the program runs the loop again, it asks, okay, what's the value of proceed right now? Because we have assigned it to false, this whole while loop doesn't get executed. So a while loop only gets executed when the condition is true. There's another way that you can go about controlling this while loop. Let's say we just put in true here. What we can also do is we can use this keyword called break. So let me show you what it does. So when you say, look, break the program, when this if statement is correct, meaning the user response is in fact equal to the right answer, right? Let's print congrats and break this while loop. So what's going to happen is it's going to exit this whole while loop. So whatever we have from line 6 through 13, we're going to exit that. So that's what this break does. And then you move on to execute the other code. So that's what break is doing. So you can either break, or you can also use what we did previously, which was to use a variable, a condition, and then to change the condition appropriately when you get the desired response. So that's how, at a very high level, a while loop works. As I mentioned before, the best way that we can learn this is by practicing. So I've created this activity called a guessing game. So let me share that with y'all. And take about 5 minutes to work on it. So let me share with you the link on programming exercises in our YouTube channel right now. And let me explain how this game is supposed to work. This guessing game is supposed to work. Okay. Okay, let the link load up for a second. Okay, it's loading up right now. Okay, one moment. Okay, so in this guessing game, what we want to do is we want the user to input a number. We want to get an integer from the user, and we have pre-decided the winning number in this guessing game to be 94. And what we want to do is we want to check to see if the user's guess is correct. If it is in fact correct, we want to just terminate the program and say, look, congratulations, you got the right number. But in the case that the user doesn't guess accurately, doesn't get the right answer, we want the program to keep on continuing, but we want the program to also offer feedback on whether the user's guess is greater than or less than the winning number. So in this case, the winning number is 94. So the idea is, in this way, the user can more intelligently guess the number. So go ahead. The time right now is about 11:52. Uh, take about, this takes a little longer. Let's take about 7 to 8 minutes. Let's reconvene back at about 12. So take about 7 to 8 minutes to work on this. And if you're done, please share the code on programming exercises so that others can take a look and learn from you as well. So time right now, 11:52. Start working on this. We'll reconvene back at 12. Okay, those who are done, go ahead and post your code on our programming exercises channel. And if you have any questions, go ahead and post them on the channel. Okay, I think people are almost done. So let's take another just 2 more minutes and wrap this up. And then we'll review this exercise and then continue on to for loops. take another 1 more minute or so and wrap this exercise up. Okay, so let's get back. So let's review this exercise right now, and then let's go on to learn about for loops. So let's take a sample response here. Give me 1 second. The computer's getting a little stuck, so give me 1 second. Okay, it's loading up right now. Okay, great. So let's run this program first, and then let's unpack the code here. So the winning number is 94. Let's say we enter a number that's less than 94. Let's say we enter 87. Okay, it says that your guess is less than the winning number. This is correct. Let's say we overshoot. Let's say we go 95. Let's just test the program out. It says that the guess is greater than the winning number. That's correct. And let's say we enter the right number. That's 94. 94. Says that we guessed right, and it stops. So let's take a look at how this program works here. So the winning number is hard coded to begin with. That was stipulated, and then we get input from the user, and it's being converted into an integer, and it gets assigned to this variable called user guess. That's fine. And then we have this while loop here, where so initially the condition is true. So this is going to be, we need to look out for the break keyword. So while true, if user guess is equal to winning number, it says you guessed right and breaks. Okay, that's fine. But else if user guess is greater than winning number, we have this message about that. And then you find that we get asked that question again. Else if the user guess is less than the winning number, we get a message, and then we get this message as well. I mean, this is perfectly fine. There are other ways of doing it as well. And feel free to share your code. But I just want to showcase a sample of one student and show that this is one way to approach it, and this is perfectly fine given the knowledge that we have just picked up. So good. So far we have learned about if statements and while loops. Another class of control structure, control flows. Another keyword that comes in really handy is the for keyword, for loops. So let's learn more about for loops right now. So when it comes to if statements, you just evaluate the condition once. When it comes to while, you keep on running the piece of code until that condition becomes false. When it comes to for loops, what happens is you specify the number of times that you want a specific piece of code to run. So for example, let me show you the syntax, sample syntax for a for loop, and then let me explain how it all works. So when it comes to a for loop, what you do is you type in for, and then you enter the name of a variable. Let's just use I in range, and then we enter the start value and the end value. Let's say we type in 1. Let's say we type in 11. Then let's say we say print. So let's run this, and then let me explain what's going on here. So what happens here? So when we specify for I in range 1 comma 11, what's going on is we're creating a range here that runs from 1 all the way till 10. So the thing you need to understand in Python is when it comes to the end value in the stop value, when it comes to ranges, that stop value is never reached itself. So it starts from 1 and the stop value minus 1. And inside of the for loop, we are printing this out. You're printing this variable. Instead of I, you could use something else as well. You could use num. Essentially, we are running through, we are iterating through this range, and we are printing out the sequence variables. That's what's going on here. Instead of range, you can also run a for loop through other things like a list. Unfortunately, we don't have the time to cover that. But essentially, anything that you can iterate over, that you can run over, iterate over, you can use a for loop to run over lists and ranges and so on. So suppose we have to print out uh, hello world 10 times. Right? One way you can do it, and this is not the best way of doing it, definitely, is to say print hello world, and then you can keep on copying and pasting it. This is the wrong way of doing it. This is an inefficient way of doing it. A far better way of doing it, since we know how for loops work, is to say for I in range 10. So the thing is, if you just key in a single parameter, a single argument here, it starts from 0 by default. Let's say you type in print hello world. So what's going to happen here is it's just going to start from 0, goes all the way till 9. So 0 through 9 is still 10 values. And so that's the reason why over here we have this string printed out 10 times. So I want to show you something else as well. So I showed you how you can have a start value and an end value, and how you can print out the the sequence tracker within the for loop. So we can have 1 here, or 2, or another number. But the thing is, when you just have the start value and the stop value in a for loop, what happens is it assumes that the next step is still 1. So let's say we type in print I. You have 2, 3, 4, 5. So it moves by +1. It moves by it adding 1 extra integer. But suppose you want to print out just the let's say you just want to print out the even numbers, right? You want the step value not to be 1, but to be 2. So in that case, what you do is, instead of keying in 2 parameters into range, 2 arguments into range, what you do is you put comma and you put 2. And if you run this, what happens is you see 2, it starts with 2, 4, 6, 8. It never reaches 10 because, as I mentioned, when it comes to ranges, the stop value that's actually used is stop value minus 1. So one of the questions that people often ask me is, when do we use a while loop and when do we use a for loop? So suppose you know how many times you want a specific piece of code to run. That's when a for loop comes in handy. You can specify, okay, run this piece of code 5 times or 10 times. But instead, if you want a specific piece of code to run until a certain condition becomes invalid, a certain condition becomes false, that's when a while loop becomes really helpful. So what we're going to do right now is we're going to do an activity where, using for loops, we're going to calculate the sum of all positive integers from 1 through 50. So let me share the exercise with you all right now. And then let's take 5 minutes to work on this so that we can consolidate our understanding of how for loops work. Okay. Give me 1 second. Let me share the link on YouTube and okay, cool. So let me explain how this exercise is supposed to work. So the idea here is that since we know how for loops work, we want to create a for loop that is able to calculate the sum of all positive integers from 1 through 50. So meaning it's 1 plus 2 plus 3 plus 4 plus 5 all the way, plus 49 plus 50. So a clue that I want to give you here is that you need to initialize a variable before you start the for loop. So you need to initialize a variable to keep track of the sum before the for loop. So that's a clue to get you started. So take a look at the sum calculator exercise and use your knowledge of for loops to attempt this exercise. So go ahead, try it out. The time right now is 12:08. Let's work on this for about 5 minutes. So 12:13 or so, let's get back and move on to functions. If you have any questions, go ahead and ask me on the programming exercises channel or the YouTube. I'm going to take a look at it right now. Take another, I think people are pretty much done. Take another 2 more minutes to wrap up this activity, and then we will review this and then learn more about functions. Okay, just take one more minute to wrap up this sum calculator activity, and then let's review it, and then let's move on to functions. Okay, so let's come back right now. Let's reconvene back. Let's go through this activity. So let me take a look at a sample response. Okay, so let's take a look at this. So let's see what's going on here. So initially we have this variable called s, and it's initialized before the for loop itself, and it's assigned the value 0. And then we have for I in range 1, comma 51. So meaning this is going to start at 1, 2, 3, 4, 5. It's going to go to 49, 50, but it's not going to reach 51. That's correct. And then what is going on here is that we are adding I to the sum. So this is keeping track of the sum, and then we are printing it out. Okay, so that's correct. Let's run it. This is 1275. That's the right value. And then the second problem, which is more of the stretch problem that I talked about, let's see what's going on here. The user creates this variable called 7 equals 0. Okay, this is fine, but you can also choose another name because this, oh, S even. Okay, got it. S even as in sum even. Okay, that makes sense. And then you loop through this for loop. You have a for loop. It starts with 2. It goes all the way till 50, and it has this step function 2. So meaning it's going to go 2, 4, 6, 8, 48, 50, right? So S even equal S even plus I. So that's being added to this tracker, and then you print this out, and this is 650, which is the right answer. So make sure that you get 1275 for the first question, and if you chose to do the second problem, make sure that you get 650. So let's move on and let's learn about functions. That's going to conclude uh, this weekend bootcamp. So let's go ahead and learn about functions right now. So first of all, why do we need functions in the first place? So functions, what they do is that they help us minimize code duplication. So suppose you wrote a piece of code to calculate the sum of, let's say, 3 different numbers, right? And let's say in another piece, in another part of your program, you need to reuse that function. You need that same, you're doing something similar. When you have a function, you can just call the function and do the same thing rather than writing the same piece of code. Now that may sound a little abstract, so let me show you how functions work, and you're going to have a better sense of what's their value. So first of all, when it comes to the syntax of function, how do you define a function? Well, first of all, you start with the keyword def, and then you enter the name of the function. Let's say I'm creating this function called my function, okay? And then you have this parentheses, and then you have a colon, and then you have an indent, and then you specify what this function is supposed to do. So let's say I'm creating this function called my function, and it's just supposed to say hello world. So right now, we have just defined the function. We're not calling the function. So now, when we run this, nothing happens, because all that we have merely done is to define a function. We haven't called the function yet. So if you want to call the function, all you have to do is type in the name of the function, with the parentheses, open parentheses, close parentheses. You run it, and then you see the function being executed. So that's how you define a function. There are lots of different things you can do with a function. So suppose, uh, so in this case, we're just printing out stuff. That's fine. But suppose, like what I mentioned, you want to create this function that can sum up the value of 3 different numbers. So let's say I put it define add underscore 3 num. So in this case, so in the first case, we didn't accept any input from the user. So this is called parameters. So we didn't have any parameters in the function. But in this case, if we want to add up 3 different numbers, we need 3 different parameters. So we give the parameters names of our own choice. So let's say I put num1, comma num2, comma num3, and then colon. And let's say I want to create a variable within my function. Let's call it total. And it's equal to num1 plus num2 plus num3. Okay? And let's say I just wanted to print out the total value. I'm not going to return anything. I'm going to explain what a return statement is within a function, but let's say I just want to print it out. So now suppose I want to call this function. I put add 3 num. And remember, we have 3 different parameters that are defined in the function itself. Now, if we want this function to work, we need to make sure that we have those 3 corresponding values. So let's say I put in 10, 11, and 12. So let's use smaller numbers to make it easier. 1, 2, 3. So when you add up these numbers, the total is supposed to be 6. So let's see what happens. You run it, and you get 6. So you get the value printed out. So I want to clarify terminology here because you may encounter this terminology later on. So when you use variables here, these things here, when you define a function, these are called parameters. But when you call a function and you fill in the values here, the corresponding values, these are called arguments. So when you define a function, these are parameters. But when you call a function, these are arguments. And you need to make sure that they match properly. So in this function, define add 3 num, all that we just did was to print the total. Instead of printing the total, you can also return the value. So meaning this is a function that takes in 3 different numbers, it adds it up, and then outputs that number. Return total. So if you return the total, you need a variable to store that output. So let's say I put total sum, add 3 num, and then I can print out sum here. Let me explain what's going on here right now. So right now, we have defined the function such that you're taking a total of the 3 numbers, and so the input is the 3 different numbers. These are the parameters. And the output is the sum. So you're returning this value. And this value, when we have this, we have this total sum variable, the value is being assigned to this variable called total sum. And that's the reason why when we print out total sum, that answer adds up to 6. So we are a little short on time. So one of the exercises that you can do, I'm going to show it right now, is how you can use functions to simplify the sum calculator that we just did. So the sum calculator that we just wrote in the for loop, the idea was, previously we wanted to sum up numbers from 1 to 50. Now let's create a function based on what we have learned. Create a function, sum up all positive integers between integers between any 2 numbers users give us. So previously, the code that we wrote, I want to explain what's going on here, was able to sum up the values from 1 to 50. But go ahead and create a function that takes in 2 values, a minimum value and a maximum value. Let's say it could be 10 to 12. It can be 10 to 20. And we want the program to sum up all the values starting from the minimum number all the way till 20. So that's the goal of this function. The thing is, we're a little short on time, so I'm just going to do it myself and then explain how this program can work. So the idea is we want to create a function that takes in a start value, an end value, and then sums up all the numbers. So let's say I call it this function define uh, summation value, and then we take in min number, let's say we call it start and end value, and then let's initialize a variable called sum equals 0. Keep track of this number. Let me use total instead. Total equals 0. And then for I in range, we want to start with the minimum value that they specify, and then the end plus 1. And then we want it to say total plus equal I. And let's say we want it to print out the sum. Print out the total value. Okay, great. So let's say we want to invoke this function right now. So I say summation value. Let's say I want to try it out from 1 through 4. So this is going to add up 1 plus 2 plus 3 plus 4. So let's run it. It's going to give us 10. So I kind of whizzed past this very quickly because we are short on time. So if you have any questions about this, feel free to ask me later on. So essentially what we did was whatever we did previously in the for loop calculator with the adding up of the sum. Now what we did was we abstracted out, used a function to do the same thing. So meaning we could have done the same thing. We can reuse the same piece of code over and over again. So we just need to key in the minimum value, the maximum value, and it does the same math for us, right? So what have we learned overall? So let's just take a step back and get a sense of what has happened here. What have we learned here? So we started out with data types, right? We learned about strings, we learned about integers, we learned about floats, we learned about how you can do mathematical operations on floats and integers. And after that, we learned about Booleans, how you can have compound Booleans. And based on the knowledge of Booleans, we learned about how if-else statements work, how you use elif when you have multiple conditions to check. And following that, we learned about for loops and while loops, and these enabled us to control the structure of the program better. And finally, we also learned about functions, and these functions help us minimize code duplication. So overall, this isn't completely exhaustive by any means, but this gives you a sense of the most important things in Python, and my hope is that this gives you a foundation that enables you to pick up more advanced concepts later on. So wrapping this all up, so what's going to happen after this class? So after this class, I'm going to post an announcement with additional practice exercises. The best way that you can learn is by practicing. So I'm going to include a couple of additional exercises for you to practice. So go ahead and take a look at those exercises. Give me a moment. Let me see if these slides load up. One moment that these slides load up. So as I was saying, so I'm going to post the additional practices on the announcements, the class announcements space. And if you have any questions about the additional Python exercises that I list there, I'm going to be online from 8 p.m. this Wednesday, EST. So feel free to ask me anything about whatever we have covered, then any issues that you're facing while working on these additional practice problems as well. And I'm also going to send you, I'm finalizing the class notes right now, and I'm going to send them via email. And next week, I'm planning on offering a data science class focused on NumPy and Pandas. These are the most fundamental packages within Python, data science. So that's what I'm planning for next week. But I'm going to send you the details via email as well. So if you found this class helpful, if you found this beneficial, please consider leaving a tip via Venmo at gpal09. Alternatively, you can also leave a donation at this website called buymeacoffee.com/gpal. Thank you so much, guys. We made it. Y'all made it through the entire 2 hours. Excellent. Thank you.